Welcome to Chemistry Online. Today we're going to talk about the metric system and simple metric interconversions. In the metric system, we use a series of SI units to describe length, mass, volume, etc. These are represented by a letter, and we're going to combine these with a prefix. The prefix is going to represent a power of 10. Pico will be 10 to the minus 12 with the prefix of P. Milli, 10 to the minus 3. If we wanted to say 1/1000th of a meter, we could do this simply by saying 1 millimeter, where the prefix M simply stands for 10 to the minus 3. Now we're going to utilize these largely when we do interconversion of simple metric measurements. We're going to use a series of ratios based on these prefixes. For example, converting millimeter and meter, we could write 4 ratios. We could say 1 meter is the same as 10 to the third millimeters. 1 millimeter is the same as 10 to the minus 3 meters. These ratios are equal to 1, so we can easily invert them, and we wind up with a total of 4 possible representations. Let's look at a simple example here for the conversion of meter and picometers. We look at our table, we remember that pico stands for 10 to the minus 12. We could therefore write 2 ratios that would look something like this: 1 meter, 10 to the 12 picometers, 1 picometer, 10 to the minus 12 meters, and of course their reciprocals. Do that again for meter and micrometers. We remember micro is represented by the Greek symbol mu and stands for 10 to the minus 6. We could therefore write these ratios: 1 meter is the same as 10 to the 6 micrometers, or 1 micrometer is the same as 10 to the minus 6 meters. Now we're going to use these ratios in a simple problem-solving algorithm, where we're going to look at our problem, pick out a number that is given, and then multiply that by a ratio. As we set up our ratio, we need to look at our given. The units of our ratio must match the units that are in the number that is given. For example, if we wanted to interconvert meter and kilometer, our given was meter. We know that 1 kilometer is 10 to the third meters, so we could write this ratio. Let's use this in a problem. Here we have an example where we want to convert 6,023 kilometers into meters. Our given here is our 6,023 kilometers. We have 2 ratios that we could write. We start off with our given. We need to pick a ratio with kilometer in our denominator. So our second ratio shown up top here works. Kilometers cancel, and we're left with an answer in meters. Let's do this again. Here we're going to convert millimeters to micrometers. We need 2 ratios, one for milli to meter and one for meter to micro. Our given is our 1.6 times 10 to the minus 7 millimeters. Here are a couple ratios. I'll start off with our given. Our first ratio, we're going to have to invert to put millimeter in the denominator. Millimeters cancel, and the units of our given are now meter. So our second ratio must have meter in the denominator. Meters cancel, and we're left with micrometers. Let's work some problems. Take each of these and do the conversion as indicated. Gram to kilogram. We remember that kilo stands for 10 to the third, so we could write something like this with gram in our denominator. Meter to micrometer. Micro is 10 to the minus 6. Meter must be in our denominator. grams to nanograms. Nano is 10 to the minus 9. Gram is in our denominator. Meter to kilometer. Kilo is 10 to the third. And finally, gram to milligram. Milli is 10 to the minus 3. Gram has to be in our denominator. Now these require two ratios. Our first one is going to be milligram to gram, and then gram to kilogram. A set that would work looks something like this. For our second, we have kilo to meter and meter to micro. A set that would work looks like this. Our next one, we have pico to gram, gram to nano, and finally our last one here. We're going from millimeter to meter, and then from meter to kilometer. The last thing we'd like to talk about here is the metric system and temperature. In this country, we're familiar with the Fahrenheit scale, where water freezes at 32 and boils at 212 degrees Fahrenheit. In the sciences, we tend to use the centigrade scale. Water freezes at 0 and boils at 100 degrees centigrade. The other measurement that we'll use when we do gas laws is the Kelvin scale. In the Kelvin scale, water freezes at 273.15 Kelvin and boils at 373.15. The important thing to note here is that there are 100 degree spaces between water boiling and freezing on the centigrade scale and the same number of spaces in the Kelvin scale. So the size of the degree is the same in both of them.